So we have the slicing method, the disc method. Next is my washer method. I'll try to make this as brief as I can. You imagine taking a peek at the graph of two equations described as such. Let's look at the region bounded by the graph of these two equations as x range from A to B, and take that region and revolve it about the x-axis. In particular, if I take a peek at maybe a rectangle over the isubinterval, if I rotate that about the x-axis, I will create what you can imagine as a washer. Hence the name, computing volumes by using the washer technique. So I do think, looking at the corresponding washer in 3 space, its volume is going to be simply its thickness, which is a small change in the y direction. Excuse me, in this case, that's a small change, my apologies, in the x direction. And I am going to multiply that by the radius, or the outer radius, I should say. And then multiply by the inner radius. Squared. Look at the difference, and that'll give you the volume of that ith washer. If I take the limit of the Riemann sum, rewrite it as a definite interval, then according to your Math 30 skills or your Calculus 1 skills, I can write that as a definite interval in the form of from A to B of the outer radius squared minus the inner radius squared. I'll factor out the delta x, but that becomes a dx when I take the limit of the Riemann sum. But of course, talking about these washers, I need to look at the area of the circles. I did indeed forget my extra factor pi, piece of cake. I'll put it in and put it outside the interval. Now, I could be revolving about the y-axis or some vertical line, in which case, these would be functions of y, that would be a dy. In general, I don't look at it this way. My little schematic is that I compute the volume by looking at pi times the interval from A to B of the outer radius squared minus inner radius squared and multiply by thickness. This way, I don't have to remember in terms of x or in terms of y. I just identify the thickness first, and everything else completely falls out. If I'm going to use the washer technique for computing the volume of a solid of revolution.